Hello everyone, welcome to this video. In this walkthrough, I'll demonstrate how to design a reliable Windows Server 2022 infrastructure using 3 key technologies that are widely used in professional IT environments. Centralized storage using iSCSI, high availability using failover clustering, automated system state backup of a domain controller using PowerShell. Throughout the video, you'll see the actual configuration steps on screen, and at the same time, I'll explain the concept, purpose, and real-world use of each task in a simple and practical way. Let's begin with centralized storage using iSCSI. In many organizations, multiple servers need access to the same storage. For example, databases, shared applications, or clustered services. Instead of installing physical disks on every server, companies use a centralized storage system. This makes storage easier to manage, scalable, and cost-effective. Is used. iSCSI allows a server to provide storage over a network, and other servers can use that storage as if it were a local hard disk. The server that provides storage is called the iSCSI target. The server that connects to and uses the storage is called the iSCSI initiator. Now, let's configure this step by step. As you can see on the screen, I'm logged into the server that will act as the storage server. First, I open Server Manager and go to Add Roles and Features. Here I'm installing the iSCSI target server role, which allows this server to share storage over the network. Once the role is installed, I move to File and Storage Services and start creating an iSCSI virtual disk. This virtual disk represents the shared storage that other servers will use. I give the disk a name and allocate the required size. Next, I create a new iSCSI target and allow access for the 2 servers that will connect to this storage. In this setup, I'm keeping authentication simple for demonstration purposes. Now, I move to the first server that will use this storage. As you can see, I open the iSCSI initiator tool, enter the IP address of the storage server, and click Quick Connect. Once connected, the storage becomes visible to this server as if it were a local disk. I repeat the same process on the second server as well. Now, on the first server only, I open Disk Management. You can see the new disk appearing as offline. I bring it online and initialize it using GPT. I don't create or format any volume here because this disk will be used later for failover clustering. At this point, centralized storage is ready. Both servers are connected to the same shared disk. The storage behaves like a local disk. This design is commonly used in enterprise environments because it supports scalability, flexibility, and high availability. In enterprise environments, certain services must remain available at all times. If a single server fails, it can cause downtime, data loss, and business disruption. To prevent this, organizations use failover clustering. Failover clustering allows multiple servers to work together as one system. If one server goes offline, another server automatically takes over. This ensures continuous service availability. As you can see on the screen, I'm installing the failover clustering feature on both servers. Once installed, I open Failover Cluster Manager. Here I run the Validate Configuration Wizard. This step checks networking, storage, and system compatibility to ensure the environment is ready for clustering. The validation completes successfully, which confirms everything is properly configured. Next, I create a new cluster. On the screen, you can see I'm selecting both servers, assigning a cluster name, and providing an IP address. After completing the wizard, the cluster is successfully created. Now, I add the previously configured iSCSI shared disk to the cluster. Once added, the disk comes online under cluster storage and is managed automatically by the cluster. With this configuration, there is no single point of failure. Services continue running even if one server fails. Downtime is minimized without manual intervention. This approach is widely used for file servers, databases, and critical applications. The domain controller is the most critical server in any Windows environment. It manages user authentication, Active Directory, DNS, group policy. If the domain controller fails and there is no backup, the entire domain infrastructure can be lost. To avoid this risk, administrators automate system state backups. A system state backup includes all critical components required to fully restore a domain controller. As you can see on the screen, I'm installing the Windows Server Backup feature on the domain controller. Next, I prepare a separate backup drive. System state backups are always stored on a non-system disk to ensure safety and reliability. Now, I create a PowerShell script that runs a system state backup automatically. This script uses a single command to back up all critical domain components without manual interaction. To allow the script to run, I configure the PowerShell execution policy. Next, I open Task Scheduler. Here, I create a task that runs with highest privileges, executes daily during off-peak hours, and automatically runs the PowerShell backup script. Finally, I verify the backup location. You can see the backup folder created with the correct date and time, confirming the backup was successful. To conclude, in this video, you've seen how to implement centralized storage using iSCSI, ensure high availability using failover clustering, protect critical infrastructure using automated system state backups. All configurations shown here follow real-world enterprise practices used to maintain reliability, availability, and disaster recovery readiness. Thank you for watching. If you found this walkthrough helpful, feel free to like and share the video.